Programs are created the same way as other objects. Right-click the backtrack's BT-1 in the tree and select Create Object. Select Program from the list, then give it a descriptive name. Now, the program can be clicked in the tree to edit it. The program editor consists of 3 areas. The upper left shows properties of the program object itself. The upper right is the list of BACnet properties the program object needs to read or write. And the bottom section is where the program code is edited. The code used is JavaScript. See the program reference page in the help file for syntax examples. There are some system variables available that start with a $sign. These provide information about the program, as well as the current time and date. The first run system variable will be true the first time the program runs after being restarted. This can be used to initialize your own variables. Here, I'll initialize count to 0. Then, every time the program runs, it will increment count by 1. The debug function can be called to print messages to the debug tab. I'll call debug here so it displays the value of count. Clicking the green Run button will make the program start running. And now we can see that the program has run 1 time and displayed the value of count in the debug tab. If we want the program to run repeatedly, the program run interval can be set to the number of seconds to wait between each run. Normally, this should be set to a much higher number, but while testing it, I'll set it to 3. Now, restarting the program will cause it to run immediately, then about every 3 seconds. Programs are expensive to run in terms of CPU time, so they should normally be run at least 10 seconds apart. In many situations, 1, 5, or even 10 minutes is sufficient. Now let's do something a little more useful. First, I'll halt the program. Then, delete the current code. We'll need access to a BACnet property, so drag it from the tree into the property list in the upper right. Notice that it is asking for a reference name. The reference name is how the property is referenced in the code. The reference name always starts with an @sign. Let's create a JavaScript variable to hold the value of the outside temperature. The value of the property can be retrieved with the getValue function, passing in the reference name. Let's verify that we are getting the value of the outside air temperature. We can do this with the debug function. We are indeed getting the correct property value into our OAT variable. Now let's convert this temperature from Fahrenheit to Celsius and store it in an analog value so it can be used on a graphic display or in another program. There are other ways to export a value out of a program. See the help file for the details. I'll debug this new value to make sure it is working properly. As you can see, it is properly converting the temperature to Celsius, but it is giving us many more decimal places than we need. Fortunately, JavaScript has a quick fix for this problem. Variables that hold a numeric value have a function that can be called to round their values to a specific number of decimal places. Calling toFixed with a 2 will round the value to 2 decimal places. There, that is much better. Now we can store this new value in an analog value object. I have already created one for this purpose, so it just needs to be added to the program's property list. I'll keep the suggested reference name, and the value of the property can be set by using the setValue function, passing in the reference name and then the value. An optional priority can be added after the value to write it at a specific priority. There are more details on how to do this in the help file. Once the program runs again, we can see that the new analog value does indeed contain the outdoor temperature in Celsius. It can now be used just as any other analog value can be used in graphic displays, trends, or other programs.